Okay. Hopefully everybody can see my screen. Okay, so thank you for joining today's session. For those of you who don't know me, my name is Matthew Merrill. I'm a cloud consultant based in Sivo's Melbourne office. And today we're trying something a little bit new. Usually, like Sivo run these brown bags on a weekly basis. And today we've got the pleasure of opening it up to some of our customers so that we can share our knowledge with them. So before we sort of get into the crux of today's content, I just wanted to go over a couple of brief housekeeping points. This session is supposed to be recorded. I'm not entirely sure whether or not it is, but it will be if it's not. And it may be posted. We are looking to post it to YouTube after the fact. So we just want you to be aware of that as you're asking questions and as we go along. And just to call out that we do have customers from a number of different organizations on the call today. So again, just if you've got any questions, just keep that in mind. As we are on Zoom, we've been playing this game long enough. I think we all know the Zoom etiquette by now, but just do us all a favor, place yourself on mute if you're not asking a question or presenting. And finally, please feel free to post any questions you might have as we go along in the Zoom chat. We've got some time at the end of the session to go through all of that. So with the general housekeeping items out of the way, wanted to sort of get started with today's content, which is an introductory look at Amazon ECS on Fargate. So taking a look at some of the managed service capabilities that Fargate offers around container-based management and operations. The agenda for today is pretty simple one. We'll start off with a brief overview of Amazon ECS for those of you on the call who are not necessarily familiar with ECS or the Elastic Container Service. We'll do a brief recap of what that is and what it's made up of. We'll then jump into what is AWS Fargate. And what is its official name, because it seems to be changing every couple of months at the moment. But we'll jump into what is Fargate and what can it do for us. We'll take a look at what problems does AWS Fargate solve. When AWS releases a new service, there's usually a reason for it. We'll take a look at what the benefits are from running a service such as this. And then from there, we'll sort of take a little bit of a look through some of the design considerations when we're looking to use AWS Fargate. I'll give you a sneak peek. Fargate is not the be-all and end-all answer to all of life's problems. There are a number of things you've got to be aware of and take into consideration when looking to leverage the service. And then once we've sort of gone through all of those, we'll open the floor up for questions. And sort of go through those, if any appear over the course of the session. So with that, time to jump into the brief overview of what is Amazon ECS. And for those of you who aren't aware, Amazon ECS is, I'll give you the official Amazon definition. It's a highly scalable, fast container management service that makes it easy to run, stop, and manage containers on a cluster. ECS, for lack of a better terminology, is AWS's container orchestration engine, much like you would have Docker Swarm or Kubernetes or any of those types of services. It is a region-based service that basically just simplifies the running of containers in an AWS manner. There are a number of ancillary services that go along with it. You've got Elastic Container Registry, which is the AWS equivalent of Docker Hub, where we can store our containers and we can pull them in, and we can leverage ECS to then run those containers and have all of the native integrations into other AWS services that we already know and we're skilled in order to be able to present containerized based workloads to our customers. So that includes things like placing behind containers behind our elastic load balancers, be they application, network. In order to present the workloads to the customers, we get all of the native integration with target groups and auto scaling groups out of the box when leveraging ECS. So when we're thinking about sort of our workloads in a containerized based environment, it's not too dissimilar to a traditional EC2 or virtual machine based environment. If we take a look at the diagram that's up on the screen at the moment, we have what would be a relatively typical sort of ECS environment, whereby we have a number of ECS instances. These are effectively our ECS hosts. They are responsible for running the individual containers that are serving the application to our end users. In this example, we've got 3 instances. Doesn't really matter if we think about them being in the one availability zone, multiple availability zones. And within each of those, we can run one or more instances of each of the relevant containers that make up our services. So, we've got a couple of front-end service containers. We've got some back-end service containers, and we've got ourselves a data store service on the left-hand side as well. And they're sort of spread across all of the available instances we've got. And then in turn, they're presented back to the users and the other components in the application via the elastic load balancers that we've got in place. So we've probably got an application load balancer serving the front end, and then a mixture serving the other components. The problem, or the main thing we need to consider when sort of thinking about a containerized environment is we have all of the wonderful tools that come with containers to automate and simplify the process of updating, deploying, patching, load balancing our workloads themselves. But in an environment such as this, we also have the hosts or the ECS instances to manage as well. We have the individual hosts that we need to scale up. If we need to deploy additional containers, we need additional instances in which to host those containers. So we need to be auto scaling our instances. We need to be managing the software that's on them. So they will be running something like an ECS agent that provides the orchestration of the individual instances. We need to update that. There's the operating system we need to patch. There's AMI images that we need to keep up to date. There is all of those BAU tasks that come with running an EC2 instance that sit very much in our realm of responsibility when it comes to an ECS environment. Now, AWS picks up a lot of the heavy lifting as far as releasing the AMIs and making the new ECS agents available, but we still maintain the responsibility for keeping our environment secure and up to date and managed accordingly. We also take responsibility for things like the security groups and the underlying networking of the instances and all of that to keep our workloads running. And this whole management layer is effectively the part that we can get rid of or we can abstract away through the use of Fargate. So what is AWS Fargate? If we think about ECS as our containerized environment, how does Fargate sort of fit into this? So AWS Fargate is a technology that you can use with Amazon ECS to run containers without having to manage servers or clusters of EC2 instances. Right? At a high level, Fargate abstracts all of the key components around running those ECS instances, those EC2 hosts, away. All right, and basically just presents it to us as a managed service. So if we take a look at the diagram on the right-hand side, effectively what it means is we still maintain responsibility for the task definitions. For those that aren't aware, the task definitions is how we define the configuration of a particular component within our application. So the container configuration, CPU, RAM allocations, volume mappings, all of those sorts of things. We still maintain control over all of that. We still maintain control over the definition of the service, which might be made up of one or more task definitions, one or more components. And we still maintain control over how those tasks and services are presented back to other applications and ultimately our end users. But as far as where those tasks are actually running is no longer within our sphere of responsibility. We can simply just turn around to AWS and say, here is my task. I would like you to run this task 3 times. I want 3 instances of this task running at any one particular point in time, and AWS will take all of that and they will manage it accordingly. So this means that we no longer need to worry about any of our bin packing strategies. We don't need to worry about making sure that we have enough ECS instances available, that they're load balanced across the right number of availability zones, that they've all got the right amount of storage, their ECS agents are up to date. All of those sorts of things we don't need to worry about. We can simply just say, here is a container, it needs 2 vCPUs and it needs 4 gig of RAM, run it please. And Fargate will simply pick up that task and it will run it. As far as everything else in ECS land, as far as our ECS cluster is concerned, as far as the underlying networking is concerned, as far as the presentation back to the end users is concerned, everything else remains the same. It is just all of that back-end compute layer is abstracted away for us. And as you can see from the diagram, we're still presenting our ENIs within our VPC the same way that we would if we were running it in ECS instances. And we still have access to all of the other services that we did before. We can still get into our Elastic Container registry. We can still communicate back to our end users, and all of this works the same way it would under a straight ECS configuration. So that's sort of a little bit of an idea of what Fargate gives us, but why, like what is the problem that it's trying to solve? And ultimately, the big one here is that operational complexity I alluded to earlier around the management of those individual ECS instances. All of that work that we do, and there are benefits to doing that work, which I will touch on a little bit later, but all of that work around managing the ECS instances, managing the ECS agent, managing the persistent storage, the networking, and all of that is just additional complexity and additional things that our teams need to worry about, need to think about, and need to be across as new changes get introduced into the environment. By abstracting all of that away and making it AWS's responsibility, it effectively means that the team can focus purely on the configuration and the operations of the containers themselves and the functionality stored within them. It also, in addition to reducing the complexity, it also reduces all of that overhead that we have. we can automate things, and automation is one of the key tenets of managing an AWS environment or any cloud environment for that matter. And look, we can automate, through auto scaling and AMI baking processes, the provisioning of the ECS instances, but not having to do that at all means, as I said before, that we get to focus our time elsewhere. Those are tasks that no longer need to be done at all within our environment. We can effectively be running a fully containerized environment and not have to manage a single underlying host for any of that. Which also means we don't need to be worrying about patching it, which means we don't need to be worrying about any of the underlying security concerns. If we cast our mind back to, was it 2019, when we think about the Heartbleed and Spectre vulnerabilities that were discovered. If we were running a traditional ECS environment, they would be patches that we would be responsible for, deploying and upgrading across our fleet of ECS instances. But in a Fargate environment, because we don't manage those boxes, that's not something that we need to concern ourselves with. AWS will pick that up, and we can focus on releasing new functionality within the application. And that sort of ties into the third one around the security. Because we're not managing, because it's not in our sphere of influence, it's a smaller attack surface within our account, within our AWS environment that we need to be focused on. Because we're not having to worry about updating the ECS agent when new versions come out. We're not having to worry about patching and updating the underlying hosts. Those are just vectors that we don't need to concern ourselves about, and we can just leverage the accreditation that AWS already has and back our service off that rather than having to worry about it ourselves. And then the last, not really a problem, but I guess more of a benefit when it comes to Fargate is, and I have to highlight the first part of this bullet point, potentially lower running costs when compared to EC2 instances. And we'll dive into that in a little bit. And we'll have a conversation around exactly what the costs are, because it can look like it's cheaper on paper, but there are some considerations that we need to sort of take into account when sort of doing the maths. And we'll walk through an example of that in a little bit. So they're kind of the four main problems and benefits that AWS Fargate has sort of been set out to address. If we sort of, like anything, because it is a managed service, there needs to be constraints put around what is possible within an environment such as this. And this sort of starts to get into the crux of those little idiosyncrasies you need to be aware of when considering whether or not AWS Fargate might be beneficial for a particular workload. And I've got a link at the bottom of the page there. If you're looking at Fargate, I highly recommend you take a look at the Fargate documentation. The AWS website goes into a lot of detail about exactly which bits are and aren't supported. But at a high level, the number one thing you need to be aware of when looking or considering Fargate is that not all task definition parameters are supported in a Fargate environment. So a prime example for that one would be privileged actions or tasks not requiring network connectivity. Neither of those types of use cases are supported in a Fargate environment. So if either of those were relevant, you would need to provision those on traditional ECS instances. Now, when we get a little bit further on, we'll have a little bit of a conversation about how you can manage that sort of thing, because it doesn't need to be an all or nothing kind of thing. You can have some of your tasks running on ECS instances and some running on Fargate, but we'll dive into that a little bit later. The next, oops. The next sort of key consideration, and depending on your underlying AWS environment, this may or may not be a particular deal breaker for your particular workloads. But the networking mode of ECS Fargate containers must be set to AWS VPC. If you're running containers in a private environment, this isn't really going to be too much of a deal breaker for you. But just remember or take it into consideration, because if you're not currently running your containers in a VPC configuration, there will be some additional work that you would have to take on before you looked at moving your containers into a Fargate style of operation. The task storage options are a little bit limited when you're talking about Fargate containers. And they're limited to EFS or traditional bind mounts. Now, for most workloads that I've dealt with, most workloads I've seen in the wild, this isn't too much of a problem. But again, this is one that can trip up people. Just because, again, there are a few additional considerations that you're going to need to think about when it comes to having your workload run on EFS. For those who may not be aware, EFS is the Elastic File System, which is an NFS-based file storage option from AWS. Now, EFS has its own set of considerations that you need to think about when looking to leverage that as a storage endpoint. And if that's something that you're looking at, feel free to reach out to your CIVO consultant, and we can go into more detail in your specific use case. The last sort of key limitation is around the reduced load balancing and logging options. The logging options have that you can only leverage AWS logs, which enables you to output your logs to CloudWatch, Splunk, and FireLens. So it's not like you don't have any logging options. It's just, again, you're traditionally funneled into your more traditional type of logging configurations. If you're using some of the more exotic options, then again, you may need to look at keeping those types of workloads within the ECS instances. And as far as the load balancing is concerned, again, it's not like you don't have any. It's not like they're massive deal breakers, but a prime example, in Australia, or in the Sydney region, for example, you can't use a network load balancer to route UDP traffic to a Fargate instance. So that may be, depending on your type of workload, a pretty big deal breaker when it comes to your workload operations. Is it coming? Is it not coming? I don't know. You can run that configuration in some AWS regions, but not in Southeast 2 at the moment. So as you can sort of see from the list, it's not an overly prohibitive list of things that you sort of need to consider when it comes to the containerized workload itself. But there are just a few in there, particularly around the networking and the load balancing, that can be deal breakers. The storage, you can typically reconfigure. The logging may or may not be too much of an issue, but it's typically the load balancing and the networking are the two biggies. At least from the types of workloads that I've looked at moving over the last sort of 12, 18 months. So I spoke before about, so that's kind of we've sort of spoken about what is Fargate. It sort of gives us the capability to not have to worry too much about the underlying compute infrastructure that goes into running our containers. We've spoken a little bit about whether or not we can use a Fargate type of environment for a particular type of container based on these limitations. What I sort of wanted to do before we sort of went any further, because if your brain's anything like mine when I first heard about Fargate back at reInvent, is that's all well and good, but it's an AWS service, and AWS services aren't necessarily the cheapest thing on the face of the earth. What does the price look like? And that'd be right, because the rain's just going to start kicking up. So I apologize for the background noise. When we're talking about pricing for Fargate, we kind of need to take a step back and think about the traditional ECS pricing first. And for the purposes of Fargate, we're really just looking at the compute component of our containerized workload. Because the load balancing configuration will remain the same. The storage, assuming you're using EFS or bind mounts, will remain the same. The networking will remain the same. We're really just looking at replacing those ECS instances with a Fargate equivalent. So it's just that compute component that we're sort of looking at. So if we think about a traditional ECS environment, with our ECS instances running on EC2 hosts, the maths is not overly complicated to work through. It basically boils down to how many EC2 hosts or ECS instances. What type of host do we need? And that will ultimately be driven by how many vCPUs and how much RAM we need. How many of them are we going to have? Typically, we would want at least 2 hosts because we're going to want to run it in a highly available configuration. And how many hours a month are we going to run it for? And well, for the purposes of the conversation, let's just say we're going to run this for 750 hours. So if we think about, if we use a relatively simple example, let's say we've got a container that's going to need 2 vCPUs and 4 gig of RAM to run. Right? It's not a particularly big, not a particularly small container. It's fairly run of the mill. 2 cores and 4 gig of RAM. Now that is pretty much the size of a T3 medium instance. But obviously, we're going to need some headroom in order to run the ECS agent and the underlying operating system and all of those sorts of things. So we're going to need to bump up and instead look at the T3 large, which is actually going to give us 4 vCPUs and 16 gig of RAM. So we need to sort of overspec it a little bit. So we'll go a T3 large. And obviously, we want a highly available solution, so we're going to need 2 of those, and we're going to need that running for 750 hours a month. So doing the maths on that one at the current, pricing as of this morning, asterisk, this may change over time, but at the current price of 21.1 cents per hour per T3 large instance, we'll grab 2 of those for 750 hours. Our compute bill runs at $216.80. Now that gives us the ability to run 2 of our containers, 1 in each of those hosts. Now the problem here is that we have a lot of additional capacity that we're not leveraging. And that is one of the real pain points that ECS sort of brings to bear, is that bin packing strategy becomes enormously important because we want to be packing these ECS hosts as tight as we can. Otherwise, we end up paying $316 simply to run 2 instances of a single, 2-core 4 gig of RAM or 8 gig of RAM containers. If we move across into the Fargate environment, the pricing for Fargate is very different. Because it's a pure consumption-based pricing model, the maths is basically just comes down to how much CPU have you consumed, how much memory have you consumed, and how long did you consume it for, in a similar way to Lambda pricing. So if we take our example here, the pricing is basically the total number of vCPU cores, so the number of cores that we've consumed times the current price, plus the total amount of memory that we've consumed times the current price, times the number of hours that we've run, times the number of containers that we did that for. So again, in our example here, we've got a container that's running, 2 cores. So it's 2 cores at 4.8 cents an hour. And then we've got to pay for the memory, which is, 8 times, half a cent per hour of RAM. We times that by 750, and we've got 2 of those containers running for a total of $209.52. And that gets us our 2 containers of the same, 2 instances of the same container running in our environment. So the costs work out, like the cost calculation is very different. And what it winds up with is a price that is solely representative based purely on what our containers consumed, rather than what the total ECS capacity that we provisioned was. And that's sort of represented when we look at when we compare the prices here. We can see that the ECS cost was $316.80. The Fargate cost was $209.52, which means just to run 2 instances of this one container was about almost $107 cheaper on ECS Fargate than it was on the traditional ECS instances on EC2. And I sort of wanted to stop on this for a little bit, because there's a lot, like on the surface, that sounds really great. Like we saved over $100, but there's a lot that sort of goes into that. The bit that this doesn't represent is that ECS environment, that $316 environment, actually has a lot of additional capacity left in it. We provision, a container with 2 core and 8 gig of RAM, but those servers are 4 core and 16 gig of RAM. So we really only provisioned a little more than, by the time you take out the overhead, a little more than 50% of the environment. So we still have almost enough to run twice as much as that, as what we're running there. So if you sort of think about it that way, were we to pack those ECS instances to 100%, we would be able to get twice as much, and all of a sudden the Fargate equivalent would be up around the $420, not the $209. So it's just that in this particular instance, we're not leveraging those that additional capacity, and hence we end up paying for a lot of capacity that we don't need. And this really boils down to one of the really powerful bits of Fargate, is because it is based on paying for the amount of the amount of resources the containers consume versus the amount of resources we're making available for the containers to consume, we get a lot more targeted price. The flip side to this is, oh, my camera just died. The flip side to this is, were we to have a high number of containers, we can see a point where the Fargate hosting costs would be dramatically higher than the ECS instance equivalent. Using that example from before, if we were to get close to 100% bin packing efficiency, the Fargate cost would actually be almost $100 more expensive. So there is a trade-off here between just how efficient we can get with our ECS environment, with our ECS instance utilization, versus leveraging Fargate and simply not having to worry about it. And after this session, we'll send out some of the resources that went into building this pack out today. And there are a couple of links in there to some recent articles that AWS have done where they actually break this down in a lot more detail. But effectively, if you're not striking about a 65, I think it's 65 or 70% utilization of your ECS instances, Fargate is actually more efficient from a cost perspective. If you're getting up around the 80 or 90% efficiency, or even closer to 100, I don't think anybody actually gets 100% efficiency out of their instances. But if you're sort of getting in that 70, 80, 90% realm, then ECS from an AWS hosting cost perspective can be cheaper. Now, the one bit that's not represented on this screen today, but absolutely needs to be taken into consideration when you're working, whether or not the price works out for you, is what we spoke about earlier, that operational effort that goes into managing those ECS instances. If you've got a team that's spending 10 hours a month or 20 hours a month updating those instances, making sure they're running, doing bin packing strategies, checking the utilization levels, then all of a sudden we're packing a lot of additional cost into the calculations here because they are all activities that we would not need to do were we to leverage a Fargate environment. So I sort of wanted to pull all of this bit together and then sort of leave the last sort of 15 minutes of the session open for questions. But basically, in summary, like Fargate allows you to focus efforts on container functionality over operational activities. And I've said this a number of times now, but really it abstracts away all of the activities, all of those tasks that aren't directly related to improving the functionality and improving your end user's experience. Making sure the ECS agent on the ECS instance is up to date and the most current version doesn't actually provide any additional functionality or capability to your end users at all. It doesn't move the needle one bit, nor does updating and patching the underlying operating system of those hosts. If you can simply move all of that to the background, make it AWS's problem, that is now time that you can focus on delivering new functionality or improving the end user experience or delivering a new service. And that's really one of the big pieces that you get out of using Fargate. It reduces the complexity of the environment. When we think about managing environments, obviously, yes, there's the overhead, right? There's those activities that we need to do every month, but also it's a learning curve for new members to teams, right? If we're onboarding new personnel, if we're bringing somebody new into the team, or we're upskilling an existing person, not having to teach them, not having to impart and manage the knowledge around all of those ancillary activities means that there's less burden on those newcomers to learn, less they have to wrap their heads around, which means, again, they can focus their efforts more on the container functionality. The other half of that is simpler environments tend not to break as much. They tend to be more secure because, again, your focus is targeted where it needs to be. We're not having to be an inch deep across 1,000 things. We're getting to go really deep on the 10 or 20 that matter. The third thing is it really changes how you think about availability and capacity. Again, when we're talking about ECS instances, we're talking about available capacity. Ideally, we want to make all of the capacity we might ever need available, right? But we don't want to do that because that's going to be incredibly expensive for the organization. So we end up boiling it back to the standard, the age-old auto-scaling conversation around where do we want our high and our low water levels to be. By leveraging something like AWS Fargate, it simply just moves the conversation to be more about right-sizing the containers themselves rather than right-sizing the containers and then also having to right-size the underlying ECS instances. It is simply just a matter of, if I need an extra 5 containers in order to keep my workload running, then I just deploy 5 more containers. And then that will just be represented in the AWS Cost Explorer and the AWS bill, the same way that any other consumption-based service is, be it Lambda or any of those sorts of things. What I see on my bill is a direct result of what I consumed rather than what I thought I might consume. So with that, sort of wanted to open the last of the session up to questions. So if I sort of move back to the chat window, I have one chat. Recording is on. So do we have any other questions or queries?
I do have one. Is it okay if I just say it?
Sure, go for it.
Awesome. Yeah, it relates to what you were like kind of talking about last there as well. When you were talking about the the lack of instances and stuff, one of the things I thought about was container-based auto scaling and cost associated with that. Like with ECS clusters I've managed in the past, we always kind of knew the upper edge of what our cost would be due to knowing the compute that we were paying for. So I guess with this kind of setup, would it be important to set kind of upper limits for the amount of containers that you're running as well, so that you've got an idea of what you're kind of so you don't get bill shock essentially. The workload I was thinking about, it was quite used in quite bursty ways. It'd either be kind of off and not being consumed or getting smashed. Yeah, no,
exactly. It's just moving where you're focusing that upper bound management. As you said, in the ECS instance world, you sort of put the upper bound on the EC2 hosts or the ECS instances. In a Fargate world, you sort of move that down and put the upper bound on the auto scaling of the service. What that sort of means is it's sort of it's a pro and a con, I guess, from the point of view that you get to target those upper bounds a lot more granularly on a service-by-service basis. Whereas with the ECS instance, you're sort of setting an environment upper bound. But of course, with that comes a little bit more of an administrative overhead because you're sort of having to apply those sorts of limits on a service-by-service basis. And as we all know, the more you get into containers, the more you tend to go into smaller services, more services, and all of a sudden you start off with 5, you end up with 30, 40 services, and that can become a little bit of an overhead. But the flip side to that is kind of, you should probably be doing that anyway. Even if you're running on a traditional ECS instance environment and you're upper bounding that, you should probably be upper bounding your services as well. So yeah.
Cool. Cheers.
Yep. What do we got? How does AWS ensure security isolation between containers on Fargate? When AWS runs the infra, does that mean that our containers are running on shared infrastructure? I don't have the behind the curtain answer to that question, other than to say it's the same set of controls that ensure security and tenant isolation across all of their other AWS services.
Sorry to interrupt you, Matthew, but I can answer that question.
Yep.
So for security isolation, it is actually a one-to-one mapping. So a single virtual machine or a micro VM is spun up, and your container lives in that. So that's why it's able to provide more security isolation. And if you are interested in finding out more about this, I can link you to a reInvent video where they dive deep into Fargate security. So happy to put that into chat as well.
Yeah, if you can put that in the chat, then I'll make sure that it gets sent out to everybody when we send out the pack after the fact. And then Chris asks, does Fargate work with EKS? Is it recommended over EC2 backed EKS clusters? Yes, Fargate does work, and thank you, Ashish, for answering that one. But yes, Fargate does work with EKS, and Ashish has been nice enough to put the link in the chat for reference on that one. But yes, it absolutely does. It does work with the Kubernetes service as well. Any other questions, queries?
Yep. Quick question about Fargate. In a lot of enterprise environments, they usually need some type of vulnerability scanning in agents. Would you still recommend Fargate in those instances, or would you, let's say, do a sidecar container inside a cluster, or find some other strategies in order for those enterprise sort of environments where they need that type of granular type of accreditation, you might say?
That is a really good question.
That's a common one when it comes to not just Fargate, but also a lot of SaaS products.
Yep. I don't actually have an answer to that, but I will get one.
It's a common one, so yeah.
No, I will get one. I will go talk to our friends at AWS, and I will get their answer on the question.
So I can probably take a dig at it again. So when you say scanning, are you referring to image scanning, or you're referring to a container running and then you want to be able to get into it and do something?
Well, let's say a bank or something like that, and they want to know, okay, we're booting up this AWS container here, but we want to be able to get accreditation for APA or some other part. Does these containers have those type of security requirements that will tick these boxes? Because if we don't get that, we don't get accreditation. So we want to install, let's say, Qualys on these agents or these containers. Do we do it at boot? Should we have a sidecar container? That's very common question when it comes to these type of products.
So for Fargate, you can run sidecars, but then for your question, so image scanning you can do image scanning for Fargate images, but then you have to be a little more specific as to what exactly do you mean? What exactly do you want to do with the container? Because sidecar pattern with Fargate is supported. Okay. So you can have sidecars, but then if you have a specific requirement around security, that's where Fargate may not be the answer, because you cannot, unlike other containers, for Fargate, you can't really SSH into them. Or if you have a requirement where you require root level access or things like that, you can't do that with Fargate.
Cool. Thanks. It's something to consider. Yeah.
So Ashish, just one thing I wanted to clarify. I recently read somewhere that AWS has come up with a new feature where you can actually shell into the container. So you need to update that container with some configurations through your CLI, and then you can actually shell into the Fargate container too now, I think.
Fantastic. I learned something new today. So appreciate if you could stick that into the chat.
Is that the exec?
Yeah.
So the one thing you got to be wary of that is that's only available on Linux containers in Fargate at the moment. But you shouldn't be running Windows containers, full stop. So you shouldn't be running. No, that's not fair. I shouldn't say that. Any other questions, queries, thoughts, concerns, issues? No. Cool. Well, in that case, I will give everybody a couple of minutes back in their day. The one thing I will close on is I am just in the final throes of pulling together a workshop, an ECS Fargate workshop, where we will actually go through the process of setting up an ECS cluster and introducing some Fargate compute capability into it so that you can actually see how you would run containers on an ECS instance, how you would run them in Fargate, and how you can run an ECS cluster using both ECS instances and Fargate capacity in order to get the best of both worlds. That will be a workshop available on GitHub and probably also the Civo blog. I will communicate out to everybody once that's available if anybody sort of wants to walk through that and give it a whirl. And with that, we'll wish everybody a happy Monday. I hope you're all, at least if you're in Victoria, hope you're all inside somewhere nice and warm because it is cold outside.
Cool. Thanks, Matt.
Sweet. Not a problem.
Cheers, man.
Thanks, Matt.
Thank you so much, man.
Sweet.